Hi guys, today we'll be looking at logarithm. So we'll start with the laws of logarithm first. And the first law we'll be looking at is what we call the single logarithm of products, which gives us addition of separate logs. What do I mean? Single logarithm of products, so law one. Single logarithm of products simply means you might be given something like this. Let's say log x times y in base a. This is going to give us log x in base a plus log y in base a. So this is what this particular law is telling us. And we also need you to understand that when you have something like this log x in base a times log y in base a, I know some of us would say, yes, this is product. So it's simply going to give us log y in base a plus log x. Okay, let me just take it. Yeah, okay, log x in base a. But actually, it is not correct. It is not correct. So I'm going to put this to show it is not equal to. So please take note of the fact that this law has to do with single logarithm of product. Please, this is very, very important. That's why I'm stressing it. So please take note of this. Now let's take an example. Let's take an example of this. You might be given something like this, say log 30 in base 6. Yeah, log 30 to the base of 6 is simply, of course, can be broken down further into log 6 times 5 in base 6. Yes, so this is now what we break further into log 6 in base 6 plus log 5 in base 6. So I hope this particular law is clear. I'm going to quickly take another example. Let me call this example A. I'm going to quickly take another example. So this is example B. Let's say we're given log 42 in base 2. Log 42 in base 2 can be splitted further into log 21 times 2 in base 2. And this is what gives me log 21 in base 2 plus log 2 in base 2. So that is what this particular law is saying. That's what this particular law is saying. And of course, we can even go from behind, meaning if I have log 4 in base 4 plus log 8 in base 4, it simply means that this is where I am coming from. Log 4 times 8 in base 4. So, however the question comes, I should be able to know what I am doing. No matter how the question comes, we should be able to know what we are doing. So that's why I'm also trying to take an example that is from this angle. So please, I need you to take note of it. Also take note that um, some people might try to say log, some people might try to say log 4 in base 4 plus log 8 in base 4 gives us log 4 plus 8 all in base 4. This is wrong, and that's why I'm putting this sign. This sign means it is not equal to. That is what it means. So please, I need you to take note of that. All right, so we are going to move straight away to the second law of logarithm. And okay, let's move this way to take the second law of logarithm. The second law of logarithm. So the second law is the single log of fractions, which gives us the difference of separate logarithms. What do we mean by that? It simply means that if we're given something like log x over y, log x over y, all in base a, then this is going to give me log x in base a minus log y in base a. So it's very important that you take note of the fact that we are dealing with a single fraction. It is very important that you take note of that. So we're going to quickly take an example. So let me just write e.g. example, example A. If we are given something like, let's say, the log of 100 divided by 5. So that's a fraction, an improper fraction. 100 divided by 5 in base 10. I can split this into becoming log 100 in base 10 minus log 5 in base 10. I believe this is very clear. So I'm going to take another example again. Let's say I am given, let's say log 25 over 4 in base 3. This is a single fraction again, remember. 25 over 4 in base 3. This is simply going to give me log 25 in base 3 minus log 4 in base 3. So that's what this particular law is telling us. So the third law of logarithm we are going to quickly look at is what we call the logarithm of a number to the same base. So this is very simple and straightforward. The logarithm of a number to the same base is something like this. Let's say we are giving log a to base a. That gives us 1. So any logarithm of the logarithm of any number to the same base must give you 1. So if we have, for example, log 2 in base 2, the answer is 1. If I have log 10 in base 10, the answer is 1. So that is that about that. Then we are going to go to the fourth law of logarithm. And the fourth law of logarithm is giving us this. Let's say we have number 4. Okay. So let's say we are given the logarithm of, let's say I'm given log x raised to power y in base a. Log x raised to power y in base a is what I'm given. So what am I going to do? This y would have to move. Remember, this y is the power of x. So this y would have to move to the other side. So it becomes y log x in base a. That's just it. Very simple. You just move the y to stay in front of the log, and then it becomes y log x in base a. So we can take an example. Let's say we are given log 27 in base 3. What does this give me? Log 27. Remember, in your indices, if you've not seen that video, you can go to the playlist and you see it. 27 is the same thing as 3 raised to power 3, because 27, 3 raised to power 3 simply means 3 times 3 times 3, and that gives us 27. So it simply means that I can make these 3 to move to the other side, and this becomes 3. This is now going to be equal to 3 log 3 in base 3. So that is it. And of course, you already remember one of the previous law we just talked about, that the logarithm of a particular base to the, of a particular number to the same base gives us 1. Therefore, the answer to this particular problem is 3, because log 3 in base 3 is going to give me 1. Then 3 times 1 is going to give me 3. So I hope this is very clear. We're going to quickly look at the fifth logarithm law. The fifth law we're going to be looking at is, let's say we're given let's say I have okay, let me write it in form of a question. If log x in base a equals to y, then if log x in base a equals to y, then this simply means that a raised to power y equals to x. So this particular law is the law that shows you the connection between indices and logarithm. And this particular law, please and please, is very, very important. You must take note of it. Now look at this. If you remember looking at the indices videos, we have whenever we have something like this, I usually call this a base. So take note, in logarithm, this is what we call our base. So when you have log x in base a to give you y, it simply means that that base also stands for the indices. So a base a for indices raises whatever you get to becoming an index, okay, and then gives you that particular log. So that's what this particular law is saying. Now we're going to solve a few problems in that direction to buttress this particular law. So let's say I am given log 81 in base x and it's equal to 4. What is this going to give me? Very simple. Log 81 in base x equals to 4. What do I do? Remember, this is my base. So according to this law, it simply means that the base raises this. So it becomes x raised to power 4 equals to what? 81. And what is 81? 81 is the same thing as 3 raised to power 4. Remember, 3 times 3 times 3 times 3 gives us 81. Therefore, since we have the same powers, it simply means that they can cancel out each other, leaving us with what? X to be equal to 3. So that's just that, very simple. So this is our first example I'm taking here. I'm going to quickly take another example for this law. Let's say we are given, uh, log 32 in base x. Logarithm of 32 base x is equal to 5. What am I going to do in this case? Logarithm of 32 to base 5, it simply means that I'm going to take this base and raise this. So this becomes x raised to power 5 equals to 32. Now, x raised to power 5 equals to 32. 32 is the same thing as 2 raised to power 5. Similarly, we are left with the same index, 5 here, 5 here, so we can cancel them out. And then our answer is going to be that x equals to 2. So that's what this particular law is saying. Then I'm going to quickly look at another law. The sixth law I want to look at. So this law says that if I have log 1, the logarithm of 1 to any base is 0. Please take note of this important law also. The logarithm of 1 to any base is 0. The logarithm of 1 to any base is 0. For example, if I am given log 1 to base 10, it is 0. Or I am given log 1 to base 15. It's still going to give me 0. So that's what this particular law is saying. Then the final law we are going to look at is what we call the change of base law. The change of base law. This law is very, very, very important. It's called the change of base law. For example, if I'm giving log x to base a, okay, and I need to change this log s in base a to a base, let's say to base, let me say b, okay. Take notes, we were given log x in base a and we need to change it to having a base of b. This is very simple. All I just need to do is to this particular term, the both the log and the base, I'm going to pick them out. So this gives me log x to base b divided by, now look at the base, divided by log a to base b. So I believe this is very clear. When you want to change the logarithm of uh, the base of a particular log, all you need to do is to do what? Divide the log of both the particular number and the base, okay? And then you're introducing the new base into the two of them. So that's just it. So thank you. I hope you've learned something. In the next video, we're going to take several examples, okay, to applying all of these laws, and then I believe it will be a lot clearer for you. Thank you and see you in the next video.